This video is going to help focus on what type of compound will form between different elements. The learning objective for this video continues the learning objective for distinguishing between molecular and ionic compounds. So when we talked about classification of matter, we talked about how matter can be classified as either pure substances or mixtures. And pure substances can either be compounds or elements. The category of compounds can be further divided into ionic compounds, molecular compounds, or acids. And each of these three categories can be subdivided even further. Ionic compounds can be separated into either type 1 ionic compounds or type 2 ionic compounds, and that's really just a distinction for when we're naming the different compounds. Molecular compounds can either be organic or inorganic, and we'll be focusing on inorganic for now and saving organic for a later chapter when we'll be naming some simple organic molecules. Then we will be talking about acids, and acids can be either oxyacids or binary acids. And so ionic compounds are different from molecular compounds in that ionic compounds form large continuous networks of cations and anions. And so large continuous networks means many atoms bonded together through ionic bonds. And so you can either shade or write pluses and minuses in all of these different things to show that they are cations and anions. So large continuous networks of cations and anions. I don't want to fill out all of them. It's going to take a long time. And molecular compounds are discrete units. Molecular compounds are discrete units. Clusters of atoms. Discrete clusters of atoms. Ionic compounds typically have high melting points. Really high melting points. That means we have to heat them up in order to melt them. As a result, they are typically solids at room temperature. Molecular compounds typically have low melting points. Even though some are solid at room temperature, many have low melting points. That means if we had an ionic compound and a molecular compound side by side and we started off with both of them being solid, the molecular compound would most likely melt first. The melting point of ionic compounds can reach anywhere from 900 degrees Celsius and up. These are typically way less than that. Melting points, well, at room temperature, some are solids, some are liquids, and some are gases. If you're a gas, that means at room temperature. If you're a gas at room temperature, that means that you've already exceeded the boiling point of that substance by reaching room temperature. So being a gas at room temperature means that you've not only melted it, but you have boiled it until it's become a gas. Ionic compounds do not conduct electricity as a solid, but they do conduct electricity as a liquid. And so this figure here is showing how a sample of an ionic compound is being heated over a Bunsen burner. And before heating, the light bulb did not light, but after heating and turning that ionic compound into a liquid, then the light bulb does turn on. And so they do conduct electricity as a liquid. Molecular compounds don't ever conduct electricity. So how can we know that molecular compounds and ionic compounds have very different properties, but how can we make predictions about whether two elements will form an ionic compound or two elements will form a molecular compound, or what the heck is an acid anyway? So Ionic compounds are made out of cations and anions, but they're overall neutral. And so to identify if something will form cations and anions, we're typically looking for a metal with a nonmetal element, or any of our polyatomic ions. And so these are on your green sheet, which you'll pick up when you come to campus, or print off on green paper so that it looks green. So we're looking for a metal and a nonmetal, or polyatomic ions with a metal and a nonmetal. Molecular compounds are made out of only nonmetal elements, so 2 or more nonmetal elements. If it contains any of those polyatomic ions, it's not going to be one of our molecular compounds. If it's an acid, then hydrogen will be listed first in the chemical formula. Acids are special molecular compounds where H+ ions fall off easily in solution. So that's why we have to list them with H first to designate that those are acids. And so that hydrogen can be either with a nonmetal element or with any of our polyatomic anions. It'll be a polyatomic anion. So I said earlier that ionic compounds could be further subdivided into either type 1 ionic or type 2 ionic. But what you need to know is that ionic compounds are always overall neutral. And so even though you are forming cations and anions, it is overall neutral. The smallest building block of an ionic compound is called a formula unit. That's going to show us what the smallest building block is. And so you can see in this figure, the smallest building block is an alternating pattern of 1 sodium and 1 chlorine ion. And so the smallest building block is 1 Na, 1 Cl ion equals 1 formula unit, which has a formula of NaCl. This distinction between type 1 and type 2 has to do with whether the cation, aka the metal, has a common ion charge or not. And so this figure here referred to the common ion charges. And so if you have one of these common metal ions, then it's going to be type 1. If you have any of these transition metals, it's going to be a type 2 ionic, because the charge varies from one compound to another depending on which anion it is bonded to. These are what's known as our polyatomic ions. So cations or anions can either be monatomic, meaning one atom, or polyatomic, meaning many atoms. And so this figure here does have different polyatomic ions, and their charges are written up in the corner. Polyatomic ions are a cluster of atoms that are held together through covalent bonds, but there is an overall charge to them. And so they behave as one ion when forming ionic compounds. And so, for instance, calcium carbonate has one, you see calcium is a metal, and then this is CO3, which is our anion. That's our carbonate anion. We can also have polyatomic cations, such as the ammonium cation, which is NH4+. The cation is always written first, anion second, in our chemical formulas. And then this is magnesium chloride. And so you can see the metal here with a polyatomic ion. This is a polyatomic cation followed by a non-metal. So you always have, if it's going to be a polyatomic cation, then that has to replace the metal. So it has to be bonded with a non-metal. And that's a metal bonded with a polyatomic ion. And so all of those are our ionic compounds. Acids can be further separated into either oxyacids or binary acids. In both cases, the hydrogen should be listed first before anything else in the chemical formula. The distinction between binary acid and oxyacid is oxyacids contain oxygen and binary acids do not. Typically, binary acids do consist of just two elements, hydrogen and something else, but you can have things like HCN, which contains no oxygen, and it's still classified and named as a binary acid, even though there's three different elements. It's just that there's no oxygen. So hydrogen with our polyatomic ions that contain oxygen are oxyacids. Molecular compounds, the smallest unit is called a molecule. The smallest in an acid is also a molecule because acids are also molecular compounds. They're just special. They have to be named separately. And so molecular compounds can either be organic or inorganic. And the distinction there is that organic molecules are carbon-based with hydrogen. So carbon bonded to hydrogen makes it organic. But inorganic compounds contain only nonmetal elements, but carbon is not bonded to hydrogen. So here we have glucose, we have ethane, and we have chloromethane. We'll name things later. So that organic compounds will be the focus of a later unit. For now, we'll be focusing on inorganic molecular compounds. You'll just have to distinguish between organic and inorganic for now. If it is a only consisting of carbon and hydrogen, then it is called a hydrocarbon, meaning hydrogen and carbon. So let's practice what we've learned by taking our chemical formulas and trying to identify what type of compound it is. Go ahead and pause the video and try to work out what compound each of these is, what type of compound it is, and then unpause the video when you're ready to go over it. Okay. So if we look on our periodic table, carbon and hydrogen are both nonmetals. I know that hydrogen is in the alkali metals, but it doesn't behave as a metal. So H behaves as non-metal. So carbon and hydrogen, both nonmetals. That means it's going to be a molecular compound. Since it is carbon and hydrogen, it's going to be organic. I'll just do that. That's prettier. Okay, for our next one, we have a metal plus a nonmetal. So that's going to tell us that we have an ionic compound. Iron does not have a predictable charge. Since it does not have a common ion charge, it has to be a type 2 ionic compound. This one is also a metal with a nonmetal. Remember, the elements below the staircase are metals. And so metal with a nonmetal is ionic. And then it also has no common ion charge, and so it should also be a type 2 ionic compound. This one we have H listed first, plus polyatomic, that's phosphate. And so it's an acid, it's an oxyacid. Since the, go to the next slide. Got it. There we go. Okay, so it's an oxyacid because it contains oxygen here. Now we have NH4NO3. NO3 is nitrate, and that's ammonium, so it's ammonium nitrate. That's a polyatomic cation plus polyatomic anion. So it is ionic. The cation does have a predictable charge, and so it's a type 1 ionic compound. SF6, sulfur and fluorine are both nonmetals. And so that is a molecular compound. There's no carbon, there's no hydrogen, so that's inorganic. Then we have HCl. HCl, we have H listed first. So we know that it is an acid, and it's no oxygen. So that is a binary acid. Lastly, we have a metal with a nonmetal. So a metal with a nonmetal is going to be ionic, and that's going to be a type 1 ionic because calcium does have a common ion charge of +2. So that is a type 1 ionic compound.